going will get worse and worse if we do these farther and farther away from the axis, but we will let's see. Okay, so rotating it around the line y equals -3, spinning it all the way around creates a solid. Right, I want to find the volume of that solid. So, what? Okay, so I need everyone agree there's a gap between the region and the line I'm rotating around. So this is definitely a washer problem. And what am I integrating with respect to? Very good. And what's my to and from? We found it yesterday. -1 to 2. And if we did need to go find that, we're finding intersections, x values of the intersection. So I need the radius of my outside circle. That's the red one, right? Well, what's the height of the red circle? It would be from the line y equals -3 up to the slanted line x plus 2. Is that the right line? So, would you agree we'll do top curve minus bottom curve to get that distance? So x plus 2 minus -3. And let's think about that for just a moment. Wouldn't this distance plus 3 get me what's the distance I'm looking for? So it works out. -3 ends up being plus 3. So it works out. Remember, I want that distance on the red circle. Any questions so far? Okay, what?
Minus the
2 what? Oh, yes. I think it's high. Like, that's the question. And I'm like, okay. Okay, but high is high. Do sound very okay, and then the next one will be the x squared curve minus -3. Okay? So what you end up noticing, if we are rotating around something other than the x-axis on a horizontal rotation, then we end up doing the curve minus that line that's on the bottom, or that line minus the curve. So that will end up being in both of your radius values. Does that make sense? Okay, and we will calculate that or do it by hand if you want it to. It could be done right. Not today. That's for another day. Okay, this is the one we started yesterday, and I'm going to start from scratch again because it's hard and it never hurts for you to see this one twice. Luckily, it's a rarity that they ever put anything quite this difficult on the AP exam. Do you need to know it? Yes. Those of you going on to Cal 3 will need to know that things get kind of yucky. But luckily, this one is harder than me and Mr. Bridges were talking about this morning. We've never seen one this hard on the AP exam. You don't even know how to do it, but it's an extra tough one. And what made it extra tough, someone remind me? I do this. We're going to run out of room, but we got this right here. So I've got an inside circle and an outside circle. But if I move down on this curve, what happens to my outside circle? It switches on which one is the left-hand curve. Does everyone see that? Where does it switch at? -1, 1, right? The y value of 1. So I'm actually going to need two integrals for this problem. Why am I dy, by the way? I'm rotating around a vertical axis, so dy. So I'm going to have to actually do two different volumes. I'm going to have to do the volume of the bottom piece and then the volume of the top piece. The bottom piece is going to be 0 to 1. Is that what we said that value was y value? And then 1 to 4. Am I right? Intersections. And again, what value on the intersection am I using? The y value because I'm integrating with respect to y. Any questions so far? So let's talk about the bottom part first. What's the inside? I'm going to draw another inside circle. What is the radius of the inside circle? So this distance on the blue circle. Okay, I like the square root of y, I agree. But it's right minus left, right? So 7 minus the square root of y would give you that distance. Does everyone agree? 7 minus the square root of y, that's a little r. The green one is the negative side of the square root of y function, right? Everyone agree? That left-hand side? So instead of 7 minus the square root of y, it's 7 minus negative square root of y, or 7 plus the square root of y. And Nicholas, back here from reminding me, put my pi there, do that too. Make sure you don't forget pi. Any questions so far? Yeah, don't forget pi. Who would want to forget pi? Any questions so far? Okay, so that's the bottom part. The top part has the same small radius. Everyone agree? The small radius didn't change. It's all dependent on the square root of y function. What does change is once we get past 1, my left-hand function is the x plus 2. Except not x plus 2. What am I going to write that function as instead? Y minus 2. X equals y minus 2. I'm going to get x by itself because I need all y's. So I'm going to have the integral from 1 to 4. What's that right-hand piece? What am I, again, remind me, what's the big radius? Okay, y minus 2, just y minus 2? 7. Are the parentheses important here? Yes. Otherwise, distribute the negative, do that however you want to. That's the big radius on the top. So that's the red circle up there, right? And then what else do I need? The little radius. Do I have to think it's hard on that one? Why not? It's the same as that left-hand little radius because the inside circle doesn't change. Right? The blue circle, as I move up, doesn't change, so I get to stick with that. Square root of 1. Okay, you can see that. I can move that picture. Okay, any questions about that one? Uh-oh. What am I missing? Pi. Okay, any questions about that? Okay, try setting up the next one. It was yucky. Is this one going to be equally yucky? Yes. Wait, no, it's okay because it's next. What the? I think about that. Next, we'll say goodbye. Oh. Make this fun. Remember, Monday there could be a I always thought I need to do it.
That would be from here to here. So yeah, I kind of lost on that part. We'll draw it. Maybe if we got what is the equation? X squared. You are going the area between these curves. Yes. In this area, we're supposed to be like this, right? So the outer, I draw that all the way around. be that right there, because it's rotating all the way around. So when you do your outer radius, it needs to be this length. How far is it from here? That's why I was wondering about because we're just talking about that distance, that right? So we don't want that negative on the side if we're talking about hitting to this part. Now this part is just extends to the curve. Right. All we need that equation is y squared, but we added this so that we can have x equals square root of y. So this is square root of y.
Okay, so let's put that together a little bit. So, we're spinning this around the line, x equals -5, correct? Yes, no, so, this is my region that's spinning around, right? Revolving around the line x equals -5, right? So, am I going to have to break this up? Let's look. If I'm at the top here, what's my inside circle? And my outside circle, right? So I'm going to move down the curve as I move down and look and see if that changes as I move down the curve. Does my inside curve change? Does everyone see that? As I move down that shape, the inside curve is different at the bottom than at the top. Everyone agree with that? Any questions about that? So everyone agrees we have to split it up? So, maybe I'll try to crack it out this time. Integral of what's my first intersection? I am dy. So what is my y value of the first intersection there? Okay, 0. Okay, to 1. So I'm going to go from 0 to 1. Plus what? It is. Yes, we're not going to do some dx and some dy. That would be pretty nasty. Not. Okay. 1 to 4. Yeah. I think so. To use an x. Okay. On the bottom piece from 0 to 1, the outside circle, the blue one, I'll use blue to color code. That's probably not going to say, but we'll try it. Okay, on the blue one, what is the distance of the radius on the bottom blue circle? Right minus left. Okay, what did you say?
So it'll be -5 minus the square root of y all squared.
It won't hurt. Typically staying right to left just to not hurt your brain. Probably, I think you're doing left to right. Right to left. Not that it matters because you're squared, you'll get the same thing. So it works. It would work out. So I'm going to do the square root of y minus -5. Right. And yes, you can do it the other way because you're squaring it, you're going to lose that negative anyway. But I'm going to stick with right minus left so I don't mess you up on area. Because when you do area, you will have to do right minus left. So we're going to just kind of stick that way so that you don't think that sometimes it doesn't matter. Because you want positive minus negative. Again, when you square it, the negative's going to go away anyway.
The other side was being a left minus right. If you're doing it around like a positive number, say
We always do right minus left.
always.
Positive minus.
So not
Because we do bigger numbers minus smaller numbers. So if we stay with positive values. Again, it turns out okay. So I don't want to completely think you're wrong. I just would rather you stay right to left. For area purposes. Okay, so square root of y plus 5 minus negative 5, which is plus 5. Everyone agree? Square root of y, which is the right-hand side of that parabola. Remember we talked about the right-hand side of that parabola was positive square root of y. The left-hand side of that parabola was negative square root of y.
why is it not minus minus
We want the blue radius.
I know all of it being right minus
Staff, please pardon the interruption. I need to see the following students from 8th grade at this time.
From something.
Riley Bagwell,
So say I
Dakota
give you-
Johnson, Samantha
Let's talk
Bowers,
numbers.
Cole Niblett, Seth Oliver, Olivia Rice,
X equals
Ethan
10.
Rye, Eli Smith, David Wycott,
How
Andrew
far
Bean,
away?
Zachary Birch, Faith Hobbs, Bailey Miller, and Isabel Rossetti from 8-3. Thank you.
so it's just like in a number line sets in your bracket.
But it keeps your numbers positive. Now for this, again, I'm going to overemphasize. It wouldn't matter. Because if you did negative 5 minus square root of y, you're going to spare it. Those negatives would end up working themselves out. But the reason I want to be careful is remember yesterday, not yesterday, 2 days ago's homework, when you did the area, if you don't do right minus, we get a negative area. If you really know what to do, yeah.
You know where it's positive. What I was thinking is farthest minus closest, and it's still messes up.
But positives stay on the right, negatives on the left. So, right, or bigger numbers on the right, smaller numbers on the left. So keep your numbers positive. So in general, I'm going to take that way. No, don't know that. Just throw you off.
It's so weird. Oh, it's
Negative square root of y minus negative 5 for the red one, the inside, the little one. Negative square root of y plus 5. Any questions about that one? Good. Is that what we got? Not down here. Now you're right up here, it would. You see how it comes in? But we so look at that shape, it's bending back in at that point. But you're right when we move over here. The blue circle on the top, is it any different than the blue circle on the bottom? No. So we can kind of copy our own work and say, okay, we've already found that. But clear on the inside, on the top, like you were saying, that red circle on the top, the inside circle is going to be line. So we're going to use that for our little radius of a second. You see that? So what was this line? Y minus 2. Is that right? Y minus 2 plus 5. Okay. Questions about that? We have one more we're going to do. Before we do, let me get you some problems. These are not due until, let me make sure I can tomorrow. Let me look so that I'm not lying to you. Tuesday on the schedule. We are rotating around by equals 4, so immediately that tells us what? Yes, right? we know it's a washer. We know it's D. So let's look. Someone with better artistic ability. Okay, so let's take a quick glance over here when I first start. Inside circle has to do with the line. What does the outside circle have to do with? The x-axis, right? Everyone agree? You gotta use the cosine curve at all at that point. Do I ever use the cosine curve? Yes. When I move past the intersection, does everyone agree? When I move past the intersection, then I inside circle. I'll stick with black for the inside circle. Is on the cosine graph. But the outside circle is still on the x-axis. So it turns out the outside circle is going to be really easy on this one because it's a cylinder, isn't it? So the radius will always be 4. Does everyone agree? Radius will always be 4. That's not going to change. The inside radius is wacky side due to the 2 intervals. So this is another nasty one. 0 to the intersection. I'm going to call that little intersection A. And not only am I going to do that on my paper, I'm going to do that in my calculator. Why am I going to do that? I want that value stored in my calculator for accuracy. So I'm going to go find the intersection. Does everyone remember how to do that? Okay, find an intersection, leave the x sitting where it is, and then go to your home screen and type x store as A. So if you leave the x sitting on the intersection in your graph, then that's what x will be in your home screen. What are you asking? We always use the washers.
Yes.
Our capital R squared.
That was, yeah.
The next one is the integral from that intersection to the where cosine crosses the x-axis. Do I know where cosine crosses the x-axis? Where at?
Out of pi over 2. Boom!
So I can find the intersection if I must. I obviously have a calculator, so you could use it. It would tell you a value close to 5 or 2, and then you have to store it just like just write 5 or 2. I am doing dx. Okay, so the outside circle from 0 to A, the green circle from 0 to A, actually on both of them, has a radius of 4. Everyone agree? So 4 squared. Easy enough. Not so easy on the inside. I have a lot more thought to go on the inside. Everyone see where I got 4? 4 minus 0 minus the x-axis. Okay, the inside circle.
Students, come your attention please. Just a reminder, if you have classes at the junior high for 6 hours, they are back, so you will need to go to your class at the junior high.
So on where I got 4, the green circle's radius all the way across the letter area is 4. We're going all the way down to the x-axis. And so we're technically doing 4 minus 0, but so what should we say on here? 4 minus. Very good. And what goes
4
here?
minus goes.
Okay, definitely. Great, thank you. And what did we get? Did y'all type that in the calculator?
Yeah.
Do that for me. Make sure you can.
There's going to be one right here. Right on top of it. And there it is.
The answer? The interval. That's fine. So tonight, make sure you do that this and wash your homework, and then start the AP problems.